Astronomers' perceptions of Mars as a geologically inert planet have shifted. Initially deemed smaller and quicker to lose internal heat compared to Earth, Mars displayed evidence of past geological vigor, including colossal volcanic eruptions evident on its surface, notably the solar system's largest volcano, Olympus Mons, observable even through amateur telescopes from Earth. However, Mars underwent a transformative period marked by the cessation of volcanic activity long ago, resulting in internal cooling and solidification, a weakened magnetic field, atmospheric erosion by the solar wind, and the freezing of remaining water. Lately, Mars has been waking up. Astronomers have been noticing some new action, shaking up their old ideas about the red planet. Insights from NASA's Mars Reconnaissance Orbiter. When it comes to space exploration, NASA is renowned for its unwavering commitment, pouring both human and financial resources into every mission. That's why it's quite unexpected that the space agency has opted to remain tight-lipped about the discovery of potential evidence of extraterrestrial life on Mars. Thousands of images captured between 2006 and 2020 by NASA's Mars Reconnaissance Orbiter offer a revealing glimpse into the Martian equatorial region. Using the high-resolution imaging science experiment HiRISE camera positioned 300 kilometers above the Martian surface, scientists were able to discern individual objects as small as 1 meter. Their meticulous study unveiled a remarkable array of landslides and debris flows cascading down the slopes of Martian volcanoes. Among the intriguing findings are over 4,500 distinctive rock patterns, resembling Christmas trees, etched into the Martian landscape. These formations, some exceeding 2.4 kilometers in length, stretch a combined distance of approximately 900 kilometers. Astonishingly, about a third of these patterns were absent in pre-2006 imagery, indicating their relatively recent formation. These geological phenomena point to powerful underground tremors previously undocumented on Mars. The InSight spacecraft, deployed in 2018, has been instrumental in monitoring Martian seismic activity through its Seismic Experiment for Interior Structure, SEIS. While over 1,300 tremors have been recorded, their intensity pales in comparison to Earth's seismic activity, with most vibrations registering a modest 3 points or lower. However, notable events like the magnitude 4.2 quake in August 2021 and the magnitude 5 tremor in May 2022 underscore Mars's subtle yet persistent seismic activity. Mars's seismic events, attributed to tectonic plate shifts and volcanic activity, offer tantalizing clues about the planet's geological evolution and potential habitability. Despite its harsh surface conditions, extreme cold, radiation, and absence of liquid water, scientists speculate that microorganisms might thrive in the planet's warmer, radiation-shielded depths. These findings fuel ongoing exploration, raising intriguing questions about Mars's past and its potential as a habitat for life. Subsurface lakes and the search for life. The recent revelation of subsurface lakes on Mars sparks excitement, hinting at the tantalizing possibility of liquid water, a crucial ingredient for life as we understand it. In 2018, radar instruments aboard the Mars Express spacecraft detected a sizable underground lake near the planet's southern pole, accompanied by 3 smaller bodies of water nearby. These aquatic marvels span an expansive 75,000 square kilometers within the vast expanse of Planum Australe, a region cloaked in ice. Further discoveries emerged in 2022, courtesy of instruments aboard the ExoMars orbiter, unveiling vast reserves of frozen or liquid water nestled within the Valles Marineris canyons. These hidden reservoirs, sprawled across an area akin to the Netherlands, lie tantalizingly close to the Martian surface, concealed within the top 3 feet of soil. Drawing parallels with subglacial lakes in Antarctica, scientists ponder the potential presence of microbial life within these Martian waters. Yet, the Martian environment poses formidable challenges. While a modicum of heat persists beneath the surface, originating from the planet's interior, it may not suffice to thaw the ice. Consequently, the lakes may remain frozen, potentially due to a high salinity content, 20 times greater than Earth's oceans, which could render them inhospitable to life as we know it. To unravel these mysteries, scientists endeavor to decipher the composition of the subterranean lake's waters and scour dried-up surface water bodies for signs of past or present life. Mars' ancient history, once teeming with lakes and rivers amidst a warmer climate and thicker atmosphere, fuels speculation about the possibility of diverse organisms inhabiting these aqueous environments. Perseverance's revelations and curiosities: methane surprises. In 2022, NASA's Perseverance rover made a groundbreaking discovery, unearthing organic molecules in close proximity to ancient water sources on Mars. While previous rover missions had encountered organic matter on the red planet, this finding holds particular significance as it was uncovered in a location rich in ancient river-lake deposits, a prime candidate for past or present life. Nestled within the 45-kilometer-wide Jezero crater, the delta formed approximately 3.5 billion years ago, accumulating layers of sediment, including sand, dirt, and salts, over millennia. Equipped with the Sherlock instrument designed to identify organic and chemical compounds, Perseverance extracted the most extensive collection of Martian organic molecules to date from the Jezero crater's sediment. Notably, the detection of hydrogen atoms bonded to carbon atoms, the building blocks of life, hints at potential biological activity. Moreover, the intertwining of organic molecules with sulfates in the crater's sediment mirrors patterns observed in terrestrial sulfate deposits, often harboring fossilized traces of ancient life. However, unraveling the origins of these organic compounds requires further investigation, with NASA planning to retrieve samples for detailed analysis on Earth. In the meantime, additional clues to Mars's potential habitability emerge, as evidenced by the Curiosity rover's detection of unusually high methane levels on the planet. With methane concentrations reaching 21 parts per billion, researchers speculate on the source of this intriguing gas. On Earth, elevated methane levels in the atmosphere are often attributed to biological emissions, prompting scientists to explore whether Martian methane is indicative of microbial activity. Alternatively, the gas may arise from geological processes, such as interactions between rock and water. As investigations continue, methane's presence offers another tantalizing glimpse into the complex chemistry of Mars and the ongoing quest to unlock its mysteries. MOXIE's oxygen breakthrough and the future of exploration. While methane captures scientific curiosity on Mars, another gas, carbon dioxide, once deemed harmful on Earth, emerges as a potential boon for the red planet's inhabitants. Enter MOXIE, a revolutionary device no larger than a toaster, aboard the Perseverance rover. Crafted from a nickel-based heat-resistant alloy, its innovative design includes a lightweight aerogel for heat retention and a thin gold coating for infrared radiation reflection, enabling it to endure scorching temperatures up to 800 degrees Celsius, the threshold for gas transformation. MOXIE's recent achievement is nothing short of groundbreaking: the production of pure oxygen from Martian CO2. This feat involves the separation of oxygen atoms from CO2 molecules with carbon monoxide as a byproduct released harmlessly into the atmosphere. While initially targeting an output of 10 grams of oxygen per hour, MOXIE's inaugural test yielded 5.4 grams, an ample supply, sustaining an astronaut for approximately 10 minutes. This compact device holds immense value, tapping into Mars's abundant CO2-rich atmosphere and utilizing regolith, a ubiquitous Martian soil, as a raw material. NASA and SpaceX visionary Elon Musk eagerly anticipates these advancements, with SpaceX's Starship slated as the inaugural lunar landing module for Artemis 3, followed by ambitious plans for Martian colonization by 2040. Musk's fervent preparations align with NASA's strategic vision, where Mars emerges as the next frontier. The envisioned settlement, likely near Mars's equator, hinges on critical resources, notably liquid water found in the Valles Marineris Canyon, a potential oasis for future settlers. With water essential for sustenance and oxygen, crucial for life support, MOXIE's continued refinement promises to address these pressing needs, paving the way for humanity's bold leap towards interplanetary habitation. NASA's Viking mission. In a surprising turn of events, a new chapter unfolds in the partnership between Elon Musk's SpaceX and NASA, revealing the discovery of ancient extraterrestrial artifacts on Mars. While these findings may be fresh to the public, they harken back to a bygone era for NASA, a journey that began in the late 1960s with the inception of the Viking mission. Led by NASA's Langley Research Center, the Viking mission, comprising 2 space probes, Viking 1 and Viking 2, he embarked on a groundbreaking quest with 3 primary objectives: capturing high-resolution images of Mars's surface, scrutinizing its atmosphere and composition, and scouring for signs of life. Launched on August 20th, 1975, and landing on Mars in 1976, each spacecraft, costing the United States approximately $1 billion, boasted an orbiter for aerial reconnaissance and a lander for surface exploration. The Viking probes transmitted thousands of mesmerizing images back to Earth, offering glimpses into Mars' geological wonders and atmospheric nuances. These images unveiled a Martian landscape scarred by ancient river valleys and adorned with towering volcanoes hinting at a watery past. Amidst these revelations, the Viking orbiter stumbled upon an enigmatic region known as Cydonia, nestled between rugged cratered terrains and smooth plains. It was here that a peculiar feature captured the world's imagination: the face on Mars. Discovered serendipitously by scientist Toby Owen while scrutinizing mosaic Polaroids, this humanoid visage, with its striking resemblance to facial features, ignited a fervor of speculation. Subsequent images from different angles only deepened the mystery, cementing the face on Mars as an enduring symbol of the planet's enigmatic allure. NASA's complex encounter with Martian anomalies. This discovery, known as the Sidonian Mesa, measuring a substantial 2 kilometers in length, ignited a flurry of conjecture within the scientific community, particularly regarding the potential implications for extraterrestrial existence. Some conjectured that the peculiar formation hinted at the possibility of past or even present Martian inhabitants, spurring contemplation on the elusive nature of life beyond Earth's confines. Notably, the unwavering commitment of visionaries like Elon Musk to Martian exploration and eventual human habitation further underscores the profound significance of such discoveries. However, amidst the fervor surrounding the potential implications of the Sidonian Mesa, NASA's response introduced a contrasting narrative. Despite the agency's primary mission objective of probing for signs of life on the Red Planet, skepticism emerged as NASA refuted the notion of the Mesa as an artifact of alien origin. Instead, project scientist Gerald Soffen attributed the striking visual resemblance to optical illusions, a stance met with scrutiny and skepticism. Further complicating the narrative were subsequent developments that fueled speculation of a potential cover-up. The absence of a follow-up image and the redirection of Viking 2 away from Cydonia to a less promising locale, Utopia Planitia, prompted inquiries into the motivations behind these decisions. Scientists, disheartened by the abrupt shift in exploration plans, questioned the rationale behind forsaking a region of optimal visibility for a less promising alternative. Cydonia, the Martian enigma. To grasp the significance of what NASA might be concealing about Cydonia, let's take a journey back in time to ancient Egypt. The Egyptians didn't erect their monumental structures like the pyramids of Giza in isolation. Instead, these structures were part of sprawling complexes, complete with temples, town squares, and palaces. Applying this logic to the humanoid face on Mars suggests a broader context of construction beyond a solitary edifice. Indeed, a closer examination reveals a cluster of pyramids surrounding the face, forming what's been dubbed the City Square. While NASA may assert these formations as natural, compelling evidence points to artificial origins. The meticulously arranged layout of pyramids, alongside features like spiral mounds and buttress walls, belies a structured urban design. Adjacent to the city square lies another intriguing feature, the fortress, resembling a collapsed pyramid. Further afield, the enigmatic DNMM pyramid captures attention. Named after NASA scientists Vince DiPietro and Greg Molinar, this colossal symmetrical structure defies conventional explanations. Measuring a staggering 3 kilometers in length and boasting bilateral symmetry, the DNMM pyramid dwarfs its terrestrial counterparts, perplexing observers with its anomalous formation. Enter Errol Torren, a satellite imaging specialist tasked with discerning natural and artificial features in Martian imagery. Torren's meticulous analysis uncovered a startling conclusion. The structures surrounding Cydonia, including the EDNMM pyramid, bear no resemblance to natural formations. This revelation hints at an ancient Martian civilization responsible for their construction, a notion supported by the EDNMM pyramid's unprecedented bilateral symmetry, defying natural explanations. Despite NASA's reticence, the DNMM pyramid stands as a testament to Mars's enigmatic past, a testament to a lost civilization whose secrets lie waiting to be unearthed.